Okay, hi everyone. Okay, so let's start OSPF. Thank you, Harpreet. Yeah, I'm very good now. So let's start. So which screen I've shared? Okay, hi. So OSPF is the topic for today. Okay, so last time also we have done some basic of OSPF, but I'll do a quick review of OSPF. तो आज हम बहुत जल्दी से रिव्यू करेंगे OSPF के बारे में. Okay, so OSPF stand for Open Shortest Path First. Okay, it is a link state protocol, and OSPF is an open standard protocol. So OSPF has a AD value 110, but in Cisco. Okay, but if you go to Juniper or any other company like HP or Huawei, so they have their own preference value, which is called route preference value. Okay, like in Juniper, OSPF has a route preference value 10. In HP and Huawei also, the route preference value is 10. Okay. So, but in Cisco, the OSPF AD value is 110. AD stand for administrative distance. Okay. Which actually tells, uh, or which is also the part of route selection process in routing table. So when we talk about OSPF, OSPF is widely used because there are a lot of companies like many companies are using Cisco plus different companies. Okay, so if you want to have communication between Cisco and different companies, like you need an open standard protocol. So suppose you have a Palo Alto firewall and you have a Cisco router, how they are going to communicate together, that is like EAGRP you cannot use between Palo Alto and Cisco. So RIP is already very old protocol. So between Palo Alto and Cisco, I think OSPF is going to be better protocol. Okay. So this is the history, like it started in so OSPF version 1 came into picture, but it was it was kind of experimental. Okay, but after that in OSPF version 2 created, and there is a research paper 1247 and 2328 you guys can check. Okay, if you want to learn in more deep way. So OSPF is a link state protocol, link state routing protocol. Link state means it is going to store the link and the state of that information. Okay, link state means we are going to maintain all the links in the database table. Okay, so in OSPF, you can have scalability, you can add unlimited routers. Okay, there is no limit in OSPF, and fast convergence. What is convergence? Convergence means if one primary link goes down, okay, अगर primary link down हो जाता है, if primary link goes down, OSPF is going to take how much time to move to the backup path. Okay, fast convergence means if OSPF has backup path, it will definitely take faster convergence. Okay, but it is not faster than EIGRP. Okay, so it is faster, but it is not that faster. EIGRP is very fast because of dual algorithm. That is a different thing. Okay, OSPF work directly on 89. Okay, so this is a protocol number. So there is a big protocol which is called IP. Okay, so under IP we have ICMP, TCP, UDP, OSPF, EIGRP, and in OSPF there is a protocol number 89. Okay, so when we talk about OSPF, okay, so these are the three things which we need to take care of. That OSPF takes a lot of memory. OSPF takes a lot of CPU. OSPF takes a lot of bandwidth. Okay, so whenever we configure or design OSPF, you need to check all three things, that when you design OSPF, okay, so it should be like designed in such a way that it will not take too much CPU bandwidth and memory. तो जब भी आप OSPF डिजाइन करोगे तो मेमोरी CPU और बैंडविड्थ का ध्यान देना है, नहीं तो OSPF नेटवर्क को अनस्टेबल कर देता है. Okay, if you do not manage it properly, it is going to create a lot of problem which is called LSA flooding. Okay, that we will discuss what is LSA flooding. Okay, so if we discuss about the design, okay, so normally if you have a location in OSPF, there is a concept of areas. Okay, तो OSPF के concept में areas होते हैं. OSPF has a concept of areas. Okay, so suppose you have a head office. Okay, like this hub is your location. Okay, this is your head office, and suppose you have different locations like Delhi, Mumbai, Chennai. So you can add those locations into different areas. So this is one of the good design. Okay, that you can add all of your branches, or maybe one location have like 4 to 5 routers, or maybe more than that. You can keep segregate all of locations into different areas, and you can place your head office in area 0. That is also a good design. Okay, so also if you see this type of design, okay, that you have multiple routers, and you can see we have all these are 4 routers are in area 0, and other areas we have also. Okay, so let's discuss about areas in more detail. Okay, so just hold on. Yeah, so okay, so guys, if you see this like design, so you can see there are 4 routers in area 0. So there is one router, second router, third router, 4 router. Okay, so these 4 routers are in area 0. They are called which routers? Backbone routers. Okay, backbone routers. Okay, and this router is going in area 1. Can you see that this router, these 2 links are in area 0. So I have written here 0 and 0, and this link is in area 1. So when a router has multiple interfaces or multiple areas, that router is called ABR, area border router. तो अगर एक राउटर एक से ज्यादा एरिया में पार्टिसिपेट कर रहा है, if any router participate in multi area, that is called ABR, which stand for area border router. Okay, and this router, so you can see this router is in 0 0. Okay, so this router in area 0 and 0 again, and this is also going in area 2. So this is also ABR. तो ये वाला router भी ABR है. This router is also ABR, but additionally this router has a link in EIGRP. So it means this router is not just ABR, this router is also ASBR. Okay, so the interview question, can a router be ABR and ASBR at same time? Yes, guys, what do you think? Can a ABR and ASBR, like, can one router be a ASBR and ABR at the same time? तो क्या एक router ABR और ASBR हो सकता है? Yes, what do you think, guys? Yes, Alan, Hardev?
Yes, sir. Yes. Yes.
Is it
Yes,
possible?
sir. Yes, sir.
Okay, great.
Yes, sir.
Okay, so yes, at the same time, a router can work like ABR and ASBR. Okay, and so any router, okay, which is not in any area 0, which is only in one area, that is called internal router. Okay, so you can see these are 3 routers. Okay, these 3 routers are which routers? Internal routers. Okay, so if any router fully completely in area 0, like this router has 2 links 0 and this all link in area 0, so this is a backbone router. तो अगर किसी राउटर के सारे लिंक 0 में, if any router has all the links in area 0, that is backbone router. If any router has any router participate in multi area, that is called ABR, area border router. Okay, and any router which participate in different protocol like EAGRP, RIP with OSPF, that is called ASBR, Autonomous System Boundary Router. Okay, so that is the concept. Okay, so here ABR stand for Area Border Router, ASBR stand for Autonomous System Boundary Router. Okay, so any router which participate in two different area is known as ABR. Okay, my question to all of you. So just imagine if a router has one link in area 1 and another link in area 2. So tell me that router is ABR or not?
ABR.
ABR.
ABR, sir.
Again, listen my
ABR.
question. I am asking, अगर एक router एक लिंक उसका एरिया 1 में है, दूसरा लिंक एरिया 2 में, if a router has one link in area 1, another link in area 2, is the router ABR?
No, sir, because it is connected with the area 0, then it will be ABR.
Yes, good, Sanjay. So till the if you do not have area 0, okay, if router does not participate in area 0, okay, so suppose you have area 1, area 2, area 3, a lot of areas, but you do not have area 0, it means that router is not ABR. समझ आ रहा है? ABR कब होगा? The router will only become ABR when it participate in area 0 plus another area. Clear, everyone?
Yes, sir.
And
Yes.
sir, those router will not communicate as well, right?
I didn't get you, Nihal.
I mean, if it is participating in area 1 and area 2, that router will not work, right? Because it need area 0, right?
Yes,
work.
correct. Yes. So if a router does not have area 0, only participate in area 1 and area 2, that is not ABR. And also they cannot communicate between area 1 and 2, because if you want to communicate from area 1 to area 2, you need area 0. Okay, good. Okay, so there is another example also. Let's see this example also. So what do we see here? There are three routers. This router, all these first square box. You can see all three are backbone routers, right? But once we have one link, so this router has 0 and 0, but this link is going in area 1. So this is why this router become ABR. तो ये router ABR क्यों बना है? This router became ABR because two links going in area 0 and this link is going in area 1. So this router is working like ABR. And also if you see this router, so ये router भी देखें तो 0 में भी है. This router is also in 0 and also in area 2. So this is why this router is ABR. But if you have any other protocol like EAGRP, OSPF in this router, so this router will behave like ASBR also. Okay. So can you have another ASBR in another area? So you can see all these four routers are in area 1. So they are called which routers? Internal routers, because all of them are in area 1. So these four routers are in area 2. So that's why again I am called these routers internal routers. But if you make any router, okay, if this router is in OSPF and RIP or maybe AGRP, so this internal router will behave like ASBR also. Because ASBR you can add in any area. Okay. You can add ASBR in any area, but there are some conditions which we will see. Tariq, no, if you do not have area 0, okay, in anywhere, then you cannot communicate between area 1 and 2. Okay, you can only do some redistribution on all, which is not recommended. But there is a way, but it is not recommended. Without area 0, it's difficult. Okay, so the quiz question for all of you. So which of the following OSPF router is connected to an external non-OSPF domain? तो कौन सा router external OSPF domain से जुड़ता है? Okay, which router is used to connect with the external domain? Okay, that router is called ASBR autonomous system boundary router. Okay, make sure you do not do any mistake while speaking your full forms, because I heard I've taken one interview long time back and the guy was saying area system boundary router. Okay, because this is area border router. So we sometimes get confused. This is also like area system boundary router. No, this is autonomous system boundary router. Okay. So this is the design. If any area, sorry. So if any area 1 wants to communicate with area 2 or area 1 wants to communicate with area 3, so area 0 is going to be like backbone. Backbone means all the traffic is going to pass through area 0. Okay. तो जितनी भी ट्रैफिक है सारी एरिया 0 के थ्रू होते हुए जाएगी. Okay, remember one thing, all areas should be connected to area 0. Okay, all areas should connect to 0. Area 0 must be contiguous. Okay, contiguous means it should be in the flow. You cannot have area 0 in Delhi and then area 0 in Bangalore. Okay, you need to be consistent while like designing a topology. Okay, so again, if you have this type of scenario in your company, okay, let me show you the picture. This is a problem. Okay, this is not a feature. Okay, so can you see these two router has area 0? Okay, then you have area 1 and after that again you have area 0. So what do you see here? There are two area 0. So what do you do? Try to do this lab, guys, if you have already done CCNA or CCNP. तो एक area 0 यहाँ पर है, फिर area 1 है, फिर area 0 है. Okay, so my question to all of you, do you think that router 1, this router 1 will be able to ping router 5 IP address? Yes. Do you think router 1 will be able to ping router 5 IP address? Ellen, I'll take your question. Just hold on. Yeah, so sorry guys about my cough. Actually, I got recovered after 5-7 days. I have eaten a lot of antibiotics and this is why I have a cough. So area 0. Okay, so this is a problem which is called partitioned area. Okay, you guys can write it down in your notebook right now. Partitioned areas. Okay, definitely we are going to discuss. We have to create a virtual link between area 0 and area 0. Actually, we need to combine these two areas 0. So that is possible with a virtual link. Okay, but yes, normally this router 1 will not ping router 5. You guys can also test. Okay, so because these area zeros are divided, so you cannot split it. You cannot split area 0, because when you ping from router 1, okay, so we are going to send area 0 information and then router 4 will not send to router 5. Okay, because when you have two area 0, it is going to create a problem. We'll discuss in virtual link. Okay, don't worry. Okay, so the question is, which area number is reserved for backbone area? Okay, this is not interview question. This is just a quiz question. कौन सा backbone area होता है? Which OSPF backbone is the by default? Obviously, you cannot change. Okay, that is area 0. Yes, correct. That is area 0. Okay. Okay, so there are 5 type of packets, guys, in OSPF. One is called hello. Then we have a DBD, LSR, LSU, and LSAC. Okay, so let's discuss about these. Okay, so what happened? Okay, please look out. Please look at the image. Okay, so let's first check the first half. So how many packets are there? Hello. Okay, so we have a hello. Okay, then we have DVD packet and then we have LSR then we have LSU, and then we have LSAC. So let's check hello packet. Okay, so basically what happened, like if two routers connect with each other, they send hello to each other. Okay, कौन सा packet भेजेंगे पहले? So they are going to send hello packet to each other. Okay, so hello. So both are going to send hello after every 10 seconds. Okay, normally we do not use a frame relay and all those technologies. So you can say hello in broadcast network or in copper cables, fiber cables. We are going to send hello in 10 seconds. So we are going to send hello packet, and the other router is also going to send me hello. So when we send hello to each other, then what we become? We become neighbor. तो जैसे ही हम एक दूसरे को हेलो करते हैं, हम क्या बन जाएंगे? नेबर बन जाएंगे. ठीक है. तो जैसे ही हमने एक दूसरे को हेलो करा, once we send hello to each other, we will become neighbor. Clear? And after that, what will happen? This router has a lot of information. Suppose we have 30 networks in this router. तो इस router में हमारे पास 30 network हैं. We have around 30 networks in this router, and this router also have around 20 to 30. So when we send hello to each other, okay, once we become neighbor, so then I'm going to share these 30 networks to router 2, right? We are increasing. Yes, we can increase the hello timer, Satyam. Okay, by default it is 10 seconds, but you can increase to 10, 20, 30, 40, whatever you want. Okay. तो जैसे आपने hello भेजा, once you send hello, you become neighbor. And once you become neighbor, you are going to share your database table. So DBD stand for database description. Okay, there are two full form of DBD. So sometimes you see DBD stand for database description, and in some books it is written database descriptor. Description होगा या descriptor होगा? Database description or database descriptor. Okay, both are similar. So we are going to send DBD packets, multiple DBD packets. Why multiple? Because we have 30 networks, right? So we cannot, maybe we will not send one DBD packet, right? Maybe we will send 30 network information in multiple DBD packet. So DBD is just to send the summary packet. Okay, so DBD सिर्फ summary भेजने के लिए use होता है. DBD packet is used to send the summary of database, not the full database. Okay, we are just sharing small information with the router 2. Okay, so the DBD packet is sent to router 2. Okay, because we send how many networks? We send 30 networks, and now this router 2 is comparing the database. Okay, तो ये क्या बोल रहा है कि मेरे पास 30 नेटवर्क हैं. I have 30 network. Please compare your database table that how many routes is missing in your table. तो कौन से कंपेयर करता है ये कि मैं आपको 30 भेज रहा हूं और आप चेक करो आपके डेटाबेस में कितने हैं कितने नहीं है. Okay, I'm going to send you 30 networks. Please compare your database that whatever routes you do not have, please send me which packet, link state request. Okay, so the router 2 is going to send LSR packet. Okay, that I need these 10 network information. Maybe the router already has 20 network information, but I am now going to send it for those 10 networks what I do not have. Okay, तो जो बचे हुए हैं जो नहीं है इसके पास वो information ये मांग रहा है. Okay, so the router is asking the remaining routes what we do not have in the database table with LSR packet. LSR stand for link state request. Okay, that I am asking for missing information. Okay, then the router is going to send the link state update by, and this update packet will be sent with all the information. Okay, LSU, and we will be sending a lot of LSU packets. And once we send LSU, we always get a link state acknowledgement also. That yes, we got the confirmation, we got all the routes. And when we have the same database table, that we call we are in full state. Okay, the database in sync. तो हमारा database sync हो चुका है. Okay, once we have the same information, it means we have the same database. Okay, and this is called urgency. This is the interview question, guys. what is the difference between neighborship and adjacency. So when you send hello to each other, you become neighbor. Okay. But maybe neighbor does not have the same information with each other. Okay. But when we send DBD packet, LSR, LSU, LS acknowledgement, when we share all the information with each other, when we have the same database table, then we are going to form the full adjacency. Full adjacency means we have the complete neighbor, full information of each other. Okay, we are more than the neighbors. We are like more like best friends, you can say. So Satyam, it's a LSR is not going to check the missing routing table. DBD is there to compare the database table. So DBD actually, once the DBD is compared, then router make LSR packet that I need this information LSR. Okay. Okay. So what we are going to do now? Okay, so we will be going to see, like we'll discuss about states also, down in a two-way start and all. But as of now, I'm going to do a practical where we'll be seeing the. So this is again. Let me give you overview again. So what will happen? The routers are going to send hello to each other. So when we exchange hello to each other, we are going to then send DBD packet. Okay, we will be going to compare the database table. And once we have the SIM database table, and if we have any missing routes, we are going to request with LSR. Okay. And link state update is a packet to share all the routes. Okay, link state update is sent to share all the update, link state update. And always when you send LSU or LSR or so every time you get acknowledgement. Okay. But hello and acknowledgement does not have acknowledgement. Okay. Hello packet does not have acknowledgement, and acknowledgement itself does not have acknowledgement. So when you send DBD packets, when you send a link state request packet, when you send a link state update packet, so most of the time you are going to get acknowledgements. Okay, तो hello और acknowledgement का कोई acknowledgement नहीं होता, but DBD, LSR और LSU के acknowledgement होते हैं. Okay, so we LS acknowledgement is a response of DBD, LSR and LSU. Okay, so once we have the same database table, okay, so then we can say that we are adjacent to each other. Okay, so tell me which OSPF packet, the following are OSPF packet type except which one? तो कौन सा इनमें से पैकेट नहीं है OSPF का? Which packet is not related to OSPF? Okay, so that is query packet. Okay, because query packet we have in EAGRP. Very good, everyone. Okay, so we are going to see how to configure OSPF version 2 and version 3 both. Okay. Okay. So let's open a lab. I need one help. Okay. Yeah, Sanjay. Yes, guys, do you have any question or because I'm starting a lab now? Don't worry, your all the concepts will be like clear. Okay, because there are a lot of things pending in OSPF. Yeah. Sanjay. Who has a question?
Hello.
Yeah, Sanjay, tell me.
सर मुझे ना अभी टॉपिक से रिलेटेड नहीं, थोड़ा सर एक क्वेरी है. एक्चुअली मैंने एक ऑफर मिला मुझे, एलिट एलिट कंसल्टेंसी प्राइवेट लिमिटेड.
अभी इस बारे में बाद में बात करें ना, अभी क्लास चल रही है.
हेलो हेलो
अभी तो नहीं ज्वाइन कर रहे हैं ना क्लास के टाइम पे? अभी साइन करके भेजने.
Hello.
Yeah. Saurabh.
Sir, I have one question, sir. Can you
Tell me.
repeat, sir, what is the difference between urgency and neighbor in OSPF, sir? I
Okay,
could
good.
not understand.
Okay. देखो, when you send
Yeah.
hello, okay? So
Yes,
when
sir.
you send
Yes, sir.
hello, so hello means just I send you hello, I become neighbor with you. Okay? So that is neighborship. समझ जाए? Hello मैंने आपको बोला, आपने मुझे hello बोला और हम दोनों अब neighbor हैं. Okay? So when we send hello to each other, we become neighbors. Clear?
Yes,
But
sir.
when we share all information, when we send, first I will send DBD packet, then you will also send me DBD packet. We will compare the database. We will check what routes we do not have. We will then send DBD packet, LSR, LSU. All these information will be shared with each other. And when we have the same database table, database means if I have 30 networks, when I will share all 30 networks with you, then we will have same database, right? So जब हमारा database table same हो जाएगा, when we have the same database table, then that is called urgency.
Yes, sir. Understand.
Clear?
Yes, sir.
Okay, good.
हेलो सर सर एक क्वेश्चन है हेलो
हाँ पूछ. Yeah, tell me.
सर एक्चुअली दो ब्रांच है सपोज ब्रांच ए ब्रांच बी अगर ब्रांच ए के पास 4 राउटर है और ब्रांच बी के पास 3 राउटर है तो ये मैंडेटरी है कि एरिया 0 देना या मतलब कि एरिया डिफरेंट एरिया मतलब कि उसको डिवाइड करना या सेम एरिया में कोई
No. If you have only like suppose, so his question is that is it mandatory to use areas? No, it's not mandatory to use areas. Okay, if you have only 7 locations in India, okay, you can just have all these locations, all 7 locations in one area. Okay, you do not have to create. So when you need areas, when you have a lot of, okay, tell me why we need VLANs, by the way, guys.
Means a lot of suppose branches
If anybody knows, अगर जिसको आंसर पता है ना कि VLAN क्यों होती है कंपनीज में, उसको वो पता है. Okay, if you know why we use VLANs,
We use to reduce the broadcast domain.
Yeah, to reduce the broadcast domain, we use VLANs, right? Because if you have a company with 5,000 employees, okay, you can have 5,000 in VLAN 1 also. But what you do, you break down into different departments: sales, marketing, admin, staff, okay, VoIP traffic, data traffic, server traffic. You divide so that all the traffic will be segregated, okay, separated from each other. So because when you have a lot of broadcast packet, it will not impact all the 5,000 users. Got it? So the same way, if you have a lot of branches like 50, 100 or 200, okay. So what will happen? Like if you have more than 100 routers, then it is always recommended to have areas. Because just imagine if you have, I'll give you one example. Okay, let me show you why we need areas. Okay, so this is आ रहा हूं मैं तुम्हारे क्वेश्चन पे, जस्ट होल्ड ऑन. Sorry. Okay, so now guys, please look at this lab. Okay, so these router 1, router 2, router 3, router 4 are in area 0, right? So just imagine if we do not have areas, okay, and suppose there is a router 2 and router 2 link down. Router 2 has a link down. So what will happen? Router 2 is going to send that update. Okay, अगर router 2 का कोई link down हो जाता है, okay, so LSA. Okay, so let's call this is a LSA packet. तो जैसे link down होगा, so once the link is down, this router is going to send LSA to router 1 and to router 4 also. So router 4 will send to router 3, router 3 will send to router 1. So what will happen? This LSA will go from each router to router, but within the area. तो ये जो अपडेट होगा ना, ये एलएसए पूरे एरिया में घूमेगा. दिस इज कॉल्ड एलएसए फ्लडिंग. Okay, let me tell you again. If router 2, suppose this link is down, the first LAN network is down in router 2. Okay, so this link is down. Okay, this link is down. So what will happen? The router is going to send LSA, which is called link state advertisement. Okay, तो जैसे ही मेरा कोई भी link down होता है, whenever my link is down, I'm going to send link state update. Okay, and I'm going to send this LSA to each of the router in my area. But the only problem, if you do not have area, okay, just imagine if all routers are in one area, then what will happen? समझ आ रहा है ना मैं क्या कह रहा हूं? अगर सारे राउटर एक ही एरिया में होते, if all the routers are in one area only, so we have to send updates to all the routers. Okay, so again, let me give you example. So just imagine if you have 1, 2, 3, 5, 6, 7, 8, 9, 10. Okay. Okay, so these all your branch offices all over the world. Okay, so just imagine in this way. Okay, and you do not have areas. All the routers you have in area 1 or area 2, area 0, whatever. Okay, so whenever a link, suppose this is Delhi router. Okay, there is a LAN network and this link is down. Okay, there is a link down of first router. Okay, maybe that is a Delhi location. So what will happen? So this router is going to flood the packet. Okay, so this is going to send a packet which is like LSA. Okay, so LSA to one router to one another router, lot of routers. So in short, what will happen? There will be a lot of LSA packets. Okay. So what will happen? There are a lot of LSA packets in my complete network. Just imagine. There are a lot of LSAs are going on, and this is going to be called LSA flooding. So just go and search on Google OSPF LSA flooding. Okay. So click on the images and now try to look for the image which will actually help you to understand. Nobody has created the image like, but yes, you got the point what I'm trying to, or just search for what is packet flooding. Okay, you will get to know that when a lot of packets are forwarded, okay, or you can search for broadcast or broadcast flooding. Okay, तो क्या problem आ जाएगी? Okay, when you have a broadcast flooding, there will be a lot of packets. Okay, and when there is a lot of packets, the devices are going to like create problem. हाँ, ये कुछ image देखो. Okay, just this is going to be the problem. Okay, routers are going to send packets to each other. Okay, the same router is going to forward to each other. Okay, so this is going to be the problem, and this is going to be called LSA flooding. Okay, so LSA flooding क्यों होगा? Because you have not divided the OSPF in areas. And this is why you are going to get a problem which is LSA flooding. So OSPF is designed in a way that when you can divide your network in different areas, you can have these routers in area 1, you can have these routers in area 3, maybe you can have these routers in area 7, so you can have these routers in maybe area 19. Okay, you can have like these routers in a different area. Okay, or maybe these routers in area 0. Okay, so this is how you guys can design. And what will happen if any link goes down here? So this LSA will only be forwarded to these routers. तो ये इधर नहीं जाएंगे. These LSA will not go from area to area. Okay, so they only 1 or 2 LSA will go to update other areas, but lot of LSA packet means all routers will not send LSA to each other. Okay. So we need to understand by looking at, like we are going to see LSA thing here. Okay. So I'm going to do a lab here now. तो अभी हम एक lab करेंगे. Okay, I'm going to create like R1, R2, R3, R4. तो अभी हम 4 राउटर ऑन कर रहे हैं. Let's on 4 routers. DBD is only the database of network. Once they compare, they send LSU to update the network which is not there with them. Yes, correct. These areas are created to have protection technique. Do you mean about what we call LSP protection or something? Thanks. LS. See, protection or those things are basically like you can design your topologies in such a way, like for every location you have multiple path. Okay, but that OSPF is not according to the protection and all what you are asking. Okay, so when you are going to learn about advanced kind of service provided thing, so like we have OSPF, there is a CSPF also. Okay, so CSPF is called Constrained Shortest Path Protocol, CSPF. Okay, तो ये एक अलग प्रोटोकॉल होता है. This is related to like MPLS. Okay, related to traffic engineering and all, and this is similar kind of OSPF but with some tweaks. Okay, so what you are asking, like protection and all those things, that is inside these CSPF and all. Okay, so that is to create LSP path. Okay, so that is a different protocol, CSPF, Constrained Shortest Path First. This is not non-normal OSPF. Okay. Okay, coming back to OSPF. So we have R1, R2, R3, R4, and we are going to turn on these routers as well. Okay, so I do not want this link. Okay, so just area 1, area 2. That's required here. Okay, I'm going to on R7 and R88. Okay, so these two routers, and we have R5, R6. No, he is not asking authentication. But he is asking about N+1 protection kind of. Saurabh, do you mean authentication? I'm sure no, right? Okay, so R1, R2, R3, R4. Yes, Saurabh is saying no. IP helper. Okay, so let's on R1. So this is my router 1. This is router 2. Let's do a lab today, guys. R3. Okay, R4. Okay, so we have R7. So we have R88. Okay, so I just on 2 routers in area 1. Okay, so when you do a lab, you guys can on all 4 routers if you want. But मैंने अभी 2 ही करे हैं. I'm using 2 routers. 9, 8 you guys can do yourself. Okay, so then we have R5 and R6. Okay, so what I recommend you, just take out this lab here. And we are going to short this. So R1, R2, R4. Okay, तो हम पहले 4 राउटर कॉन्फ़िगर करते हैं. R1, R2, R3 and R4. Okay. Okay, R1. Okay, so how you configure OSPF? That is very simple. So enable config T host name R1. Okay, so this is my R1. So let's give the host name first so that we do not do mistake. Okay, so enable config T. So okay, host name, this is R2. Enable config T host name R3. Host name R4. Okay, so let's give IP address here, guys. Interface FA00, IP address 192.168.12.1. And there is FA01 IP address 192.168. 13.1. Okay, so how you configure OSPF? Let me tell you the easiest way. Okay, so we will be going to say interface FA00. I am going to add all 4 routers in which area? Area 0. तो अभी मुझे सारे routers को कौन से एरिया में डालना है? I have to add all 4 routers in area 0. So you can just run this command, which is very simple. IP OSPF. Then you can give a process ID. I would recommend you should use same process ID. Okay. So I'm taking 1 process ID 1 and area 0. Okay, so go to another interface and give the same command IP OSPF1 in area 0. That's it, guys. That's it. OSPF is configured. Okay. So last time I think I have shown you network command. Okay. So now if you check show IP OSPF interface brief, you can see both the interfaces are activated with OSPF. तो दोनों इंटरफेस पे OSPF चल पड़ा है. R1 FH01, R1 FH00, both the interfaces are activated with OSPF1 area 0. So this area 0, okay, and this one is called PID. PID is process ID. Okay, so whenever, like if you check here, show process CPU include OSPF, it means the router started OSPF process ID 1. Okay. So it's like an application, like if you have a task manager, okay, like you have a resource monitor in what we call activity monitor and all, like you have task manager in computer, right? So all your applications in your laptop running, okay, and you can see my laptop has Zoom, packet tracer, a lot of things going on, and all my application has a process ID. So you can see here, I have a process ID in my computers also. So the same way, when you run OSPF process ID 1, it only means that I am running a OSPF which has a process ID 1. Okay. So if you run maybe router OSPF 2, okay, so in advanced practicals, you will see that you have to configure multiple OSPF. Okay, so if you check show process CPU in OSPF, so you can see OSPF1 is a different process ID and OSPF2 is a different process ID now. Clear everyone? Okay. ठीक है, तो अभी यहाँ से समझ आ गया कि एक राउटर पे हम ज्यादा प्रोसेस भी चला सकते हैं. ओके, सो नॉर्मली वी रन मल्टीपल OSP process in the case when we are ISP. Okay, we need to run multiple routing tables. In that case, we use a different process IDs. Okay, but as a company, as an enterprise company, most of the organizations are going to use one process ID. Okay. Okay, so router 2, let's go to router 2. Router 2 interface F00, IP address 192.168.12.2. Interface F01, IP address 192.168.24.2. Okay, so I'm taking .2 in router 2 and FA1/0, which I'm going to use later on, but I'm going to add this 192.168.27.2. Okay, so I configured FA1/0 also, which is going in area 1, which has a subnet 27.2. Okay, so we configured IP addresses, guys. Okay, so you can see, and let's go FA00 in which OSPF in area 0. Very simple. FA0/1, again, that is also area 0. But this link, which is FA1/0, ये जो FA1/0 है ना, ये area 1 में जा रहा है. Okay, so FA1/0 is going in IP OSPF 1 area 1. Okay, can you see that? These two links in area 0 and this is area 1. So once you enter this command, okay, so once you enter this command, okay, you guys can verify that show IP protocols. Okay, so show IP protocols will tell you that you are running OSPF and this router is an area border router. Why? Because two interfaces you have in area 0 and one interface you have in area 1. And automatically this router became area. Sorry. ठीक है, तो ये क्या बन गया है? This router is area border router now. Clear? Okay. So let's go to R3, which is again one of the router we have backbone. Okay, so interface FA01, IP address 192.168.13.3. Okay, this time I'm directly going to write the command here. IP, after IP, no shutdown IP OSPF1 area 0. So this is how you should configure in the labs. IP though, फिर no shutdown, IP, no shut, and after that you guys can directly add the OSPF command. IP OSPF1 area 0. That's it. R3 is also configured, guys. And let's go to R4, which is also ABR because this R4 has 0 and area 2. Okay, so we'll give IP FA01, IP address 192.168.34.4. Uh, 24.4. $45, I think. All my last octets are 4 of this router. Okay, so interface F is, and you can also configure multiple interfaces in area. Okay, so interface range FA00-1. Okay, because both my interfaces are in area 0, you can directly configure two interfaces, IPOSPF 1 area 0 and interface FA1/0, IPOSPF 1 area 1. Oh, not area 1, it's area 2, guys. Okay, तो यहाँ हमें area 2 देना है, IPOSPF1 area 2. Okay, so how you verify show IPOSPF interface brief? Okay, so that is configured here also. ठीक है, okay यहाँ तक. So if you go and see the beauty of all 4 routers now, because they have already created neighborship, how you guys can check where neighborship show IP OSPF neighbor. तो क्या कमांड है नेबर देखने की? What is the command to check neighborship? Show IP OSPF neighbor. So what do you see here? There is a neighbor ID. Can you see a neighbor ID here? Yeah. Okay. So what is the neighbor IP, guys? On router 1, who all my neighbors? Router 1 is a neighbor with router 3 and router 2. Okay. So router 3 has taken what IP? 13.3. Okay. But this router also has 34.3. Yes or no? Yeah. So this is 27.2, which is router 2 IP. So this is that I am making a neighborship with the neighbor ID. Okay, we'll discuss about router ID also. Okay, but I'm using normal physical IP to create a neighborship. And also, like, this is dead timer, which is 40 seconds. If 40 seconds means after every 10 सेकेंड दिस टाइमर विल रीसेट टू 40. तो हर 10 सेकंड के बाद ये टाइमर 40 हो जाता दोबारा. ओके, आफ्टर एवरी 10 सेकंड दिस टाइमर अगेन बिकम 40. सो व्हाट इज डेड टाइमर? So dead timer means if you do not send me hello, because I send hello after every 10 seconds, but if I send you hello, but if router 2 or router 3 do not send me hello back, okay, I'm going to wait till 40 seconds. And once this timer becomes 0, I will remove neighbor. तो अगर मुझे ये टाइमर उल्टा चलता है, okay, this is a countdown timer. If it becomes 0, okay, and if I'm going to remove the neighbor, but once I get hello from other side, I will again reset to 40. If you check here, what is happening after you can see 39, after that again 39, and again now timer is going down, 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 and after now we will send hello again, and again it from 31, okay, फिर hello मिला मुझे, फिर 39 हो गया. देखो, means after every 10 seconds this timer go till 30, 31, and again when we receive hello, again we reset to 40. Okay. Okay, so that is the thing, and you want to see the details, show IP OSPF interface. Okay, so you guys can run this command also. It will give you much more details. तो ये detail बहुत जरूरी है. So when you run this command, show IP OSPF interface, it will show you that you are running this process ID 1. Okay, so the timer of hello packet is 10 seconds. The dead timer is 40 seconds. Okay, so the wait timer is also like same dead and wait similar. Vidyut, I think what you have to do. So one student is not able to join the class. Actually, you have to go to this website, which is live.nwkings.com. There you have to attend the live class. Okay, live.nwkings.com. So once you log in with their ID, okay, it will show you some batch, and then click on that batch and join. Okay, so hello timer 10 second, dead timer 40 second. Okay, what do you see here extra? Okay, so this is my this is my another neighbor. Okay, we'll see more details. So we have seen the neighbor table. Okay, show IP OSPF neighbor. This is the command which is good. Then show IP OSPF interface brief, which is also very good command to check the cost, also to check the process ID, area ID, everything. Okay. Also, you guys can check show IP OSPF database. Okay, so now what we have to see, these 4 routers are generating router LSA. Can you see? Router LSA. router link state. Okay, so these 4 routers are in which area? Area 0. So how many routers participating in area 0? 4 routers. So this is why all 4 routers are going to create or generate a router LSA. Because I told you OSPF is a link state protocol. We are going to maintain the link of all the routers. And when you are in one area, okay, suppose you have 10 routers, 20 routers, or 100 routers, all routers are going to add his link in the router LSA. So the first LSA, so this is a database table. The top thing is called router LSA. So now just imagine if you have these routers without area, if you have 100 routers, then how many LSA you will see in the database table? अगर आपके 100 राउटर होते एरिया 0 में तो कितने एलएसए दिखते हैं यहाँ पे? How many LSA you will see if you have 100 routers in area 0? Siddharth, not 99. If you have 100 routers, you will see 100, not 99. You have to count your router also. I'm checking on R1. You can see our R1 is showing his own IP also. Okay. So if you go and see the best thing in R1, R2, R3, okay, if you check any other router, like let me check here R2 separately. Okay, if you see the database of R2, show IP OSPF database. So this router and router 1, you can see. Please only check this section. Tell me both are same or different. दोनों का ये check करो. So tell me both are same, exact same, or only age is just how much time back we got the update. Okay, age is कि कितने time पहले मिला है. This is in millisecond. Age is timer, how much time back we added this link in the database. But rest all the things are same. Can you see? Yes. Okay, so when we started the class, I told you, like in OSPF needs to have these 3 things very, very optimized: memory, CPU, and bandwidth. Okay, so in OSPF, like you need to control the excessive LSA generated by all routers. Excessive LSA को रोकना है हमें. Okay, we should design in such a way that it will not take too much CPU, lot of bandwidth also not taken by any area. So how it is possible? When you divide the OSPF in areas, because if you do not divide areas, the problem will be like too much. Okay, because if you have all routers in one area, then the database table will also increase. And where you have database table, tell me in which memory, कौन सी memory में होगा database table? What do you think? Is it in flash memory of router or it is in RAM of a router? It is in the RAM. Okay. So now tell me, if the router has to process LSA, it has to check the database table. And if the database table is very big in size, so router, CPU and memory will get affected. Yes or no? अगर सारे 100 LSA यहाँ दिखेंगे तो आपको नहीं लगता है उसका memory, CPU and all high होगा, right? So definitely that is the case. This is why we have OSPF areas. Okay. So now let's come back to the point. So router LSA, it's clear. Okay, we'll discuss about what is the sequence number, what is checksum value, what is this link count. Okay, link count, that how many links we are getting from these neighbors. Okay, and sequence number and checksum we'll discuss. Okay, don't worry. But now, okay, so in OSPF, there is a concept of DR BDR. Okay, so in OSPF, there is a concept of DR BDR. We need to learn about DR BDR first. Okay, So let me show you something. Okay, so when you connect two routers, okay, so when suppose you have two routers, okay, and you connect OSPF here. Okay, so do you think there will be a DR BDR election here? So if you do not know what is DR BDR, DR stand for designated router and BDR stand for backup designated router. Okay, तो एक होता है DR और एक होता है BDR. Okay, DR and BDR. Okay, so why we have DR BDR? Okay, the same answer. Why we have areas? Remember, whenever somebody asks you why you have areas in OSPF, the answer would be to stop LSA flooding, to make better design. Okay, but the main point, you have areas. Okay, so we have areas. Why we have areas? Why we have areas in OSPF? The answer is, okay, to reduce the LSA flooding in OSPF network, we have areas. Okay, there are other options also. You guys can write here to control the CPU, memory, and bandwidth of my network. Okay, to control the CPU, memory, and bandwidth. Okay, so you can add multiple points. Okay, but why we have DR BDR? Why we have DR BDR in OSPF? तो ये क्वेश्चन बताओ मुझे. चलो एरिया तो मैंने तुम्हें बता दिया. Okay, trust me, 80 to 90% people fail in interviews. They do not know actually why we have areas. They have the same answer. सभी लोग यही बोलते हैं because OSPF is designed in such a way. Okay, nobody gives clear answers. Okay, yeah, definitely OSPF is designed in a way that you have to use areas, but why? Why we have DRBDR? Okay, so let me tell you why we have DRBDR first. Okay, so first we need to do a small lab of DRBDR. Okay, so we will be taking because in packet tracer I can show you better way. Okay, तो इसीलिए मैंने लिया. Okay, so just imagine we have around 4-5 routers. Okay, and now I'm connecting all these routers. Okay, so just imagine all these are your locations like Delhi, Mumbai, Chennai, Kolkata, Chandigarh, whatever. Okay, so just you connected with one of the device. Maybe this is a data center switch where all the links are connected of all your location, or maybe this is your hub location. Okay, intranet. Let's call intranet. Sorry. Okay, so let's give IP address here, any subnet here. Okay, let me add here 1.1.1.1. Okay, so let's give IP address on these routers. So I'm just using shortcut method little bit. I'm just giving IPs. You can give IPs with the command line. I am just getting lazy. Okay, so we have given IPs here and we are going to run OSPF. Okay, how you run OSPF? Remember in OSPF, like we can use a network command also. Okay, like 1.0.0.0 and wildcard mask. Okay, So 0255255 area 0. तो आप ये कमांड भी दे सकते हो. Okay, do not get confused that I studied this way and you are showing me something different. Okay, but normally interface method is better. Okay, so this is router 2, router 3. Okay, let's give network command. This is router 6. Let's give network command. Okay, so it means in all the routers, we need to give the same command. Okay, so we have given, and after some time, what will happen? You can see router 2 is has a neighborship with all routers. So this router, is router ke kitne neighbor hain? This router is connected with a switch. So it means they are all in same network. 1, 2, 3, 4. So router 2 will have 4 neighbor. How you can verify? By giving show IP OSPF neighbor. Right. So what is happening by default? Do you see there is some DR, BDR, something written over here? Okay, why? So, so the concept of DR, BDR. Yes, yes. Okay, so normally what happen, guys? Okay, so suppose like there is a link down here. Okay, so what happened? Let me create a loopback here for testing. तो यहाँ मैं एक loopback बना रहा हूँ इस router पे testing के लिए. Okay, I'll create a loopback here for testing, maybe like 4.4.4.4. Okay. Okay, I'm going to create a loopback for testing here, and I'm going to add that network. Okay, so remember when you create a loopback, IP address 4444 like this. Okay, and now you are going to add this in OSPF with network or interface command. Okay, area 0. But before I enter, I click on simulation mode. Okay. And you can click on show all, show none. Okay. And just select that I want to only see OSPF packet. Okay. So currently we are going to monitor the OSPF packets here. Okay. So what I'll do here, I'll click on when I enter the network command. Okay, it is not showing me. Yes. So there is some update here. Just hold on. Let me try to check again. So when I remove no, I think all the packets I need to turn on. Okay, so let's check again. Okay. Okay, so there is a network here. Okay, so whenever you create an update here, I just created a loopback here for testing. Okay, and you can see I created 4444 and I have added this in 4 network. Why it is not showing me a packet? Okay, it should show me a packet here. I don't know why it is not showing me. Okay, so let's use a computer here, a LAN network. तो एक LAN network बना लेते हैं. Let's create a LAN network here. Okay, so I'm going to give IP on this interface GI001. Interface GI001. IP address like 192.168.1.1. Okay, so you can see once I given no shutdown, it is showing me packets. Okay, and now I'm going to add this in router OSPF1 network 192.168.1.0 area 0. Okay, so you can see OSPF update is also going. So what actually I'm trying to show you that you created a LAN network here 192.160. Leave the loopback, guys. Abhi loopback bhul jo. So there is a LAN network 1.0 and you got all the routers got the update of the LAN network, right? You are receiving OSPF route. O means OSPF. तो आपको route आ रहा है. You are getting routes there. So so now I'm showing you simulation mode. Okay, so once the simulation mode is active, okay, so just imagine if this FA01 is down. Okay, so if FA01, this interface from switch side, if this link goes down, you can see once the link down, the OSPF created update. So you can click here. You can see this is a OSPF link state update and it is going to 224.0.0.6. Can you please note it down? So when there is a link down, whenever there is a problem, whenever there is a new information came, चाहे नया network हो, चाहे पुराना हो, if anything move add, if anything is added, if anything is deleted, the router is going to create a link state update. 224.0.0.6 is destination address. Okay, so it means 224.0.0.6 is the update. Okay, so you can see, and now I'm going to forward this packet to the switch, and switch is going to broadcast this to all the devices. Okay, but all these two routers are not accepting the packet. Why? Because remember, when there is update, the update was of which address? 224.0.0.6. So 224.0.0.6 is the multicast address of DR BDR. I told you DR and BDR has a special routers in OSPF which listen for 224.0.0.6. So ये दोनों router, both routers are like president and vice president kind of. Okay, DR is like the leader and this is like the backup leader. Okay, so means if any changes happens in the company network, we are going to inform to DR first. Okay, so what is going to happen here? That I am going to inform that my link is down. I will inform my DR. Who is DR? I think this router is DR. So I will show you how to check who is DR, but I will first send a packet to my DR. Okay, I will also update my BDR also. But BDR will not do anything because DR is active. तो BDR कुछ नहीं करेगा क्योंकि DR active है. When DR is active, BDR will not do anything. So now once you update the router 2, okay, that I got a link down. Now this router is going to create a packet. Okay, and now it is going to send the packet to 224.0.0.5 and 5 is listened by all routers. Because DR is like the monitor. Okay, means anything happens, go and inform to DR. तो कोई भी problem आता है, whenever you get any problem, please go and inform to DR. Okay, designated router, and then DR is going to forward. No, Amit. DR, BDR both has 224.0.0.6, and all OSPF router listen for 224.0.0.5. Okay, 5 is for all OSPF routers, but a 6 is only for DR and BDR. Okay, so DR, ये देखना अभी. Okay, let me show you. I'm sending an update to 224.0.0.6. Okay, so this update will go to DR. You can see these packets are not able to understand because they are not DR and BDR. This is why you can read the packet also, guys. The device receive OSPF packet for backup and DR the device drop the packet. Because this router is not DR or BDR, this is why they are getting rejected. But this router, if you see, has also created a reply packet. BDR is not creating any reply packet. ये BDR है. This is a BDR router. It is not doing anything, just accepted the packet. Thank you very much. But DR created a reply packet here. Once you send a packet, the router created a reply. Okay, you can see now this packet will go to 224.0.0.5 because this is for all OSPF router. You inform the DR and DR inform. Now DR is informing all OSPF router including you, and now all got the update. There is a link down in Delhi branch. यानी अब सारे routers को पता चल गया है. All OSPF router came to know there is a problem in this router. Clear, everyone? Now you got the point. What is DR, BDR? Okay, so normally this happens. This DR, BDR selection is happening when you have this kind of design, like when you have broadcast domains, when you connect multiple routers with switches. That is, so this type of design is called broadcast domain. Okay, this is called broadcast network. So broadcast network, when you have a switches, okay, this type of design is called broadcast network when you are using Ethernet cables or Ethernet technology. Okay, so because when you have this type of design, okay, just imagine if we do not have DR, BDR, what will happen? अगर DR, BDR हमारे पास ना हो तो क्या हो? If we do not have DR, BDR, we will send to all routers and all routers will send their neighbor. Means we will have the problem what I have shown you earlier, okay, which is called like broadcast storm kind of, or broadcast flooding. If you remember that image. तो problem हमें क्या होने वाला है? We are going to have this problem. Okay, in this case also, if you do not have DR, BDR. So we have DR, BDR so that my company network will be optimized and automatically DR, BDR will be selected. And how they are selected now, let's discuss. कैसे ये select होते हैं? How they are selected? So first, all routers have a priority. So if you check here, show IP OSPF interface brief. ये command, so this command does not work on packet tracer. But if you check here, show IP OSPF interface. So this interface, all OSPF interface has a priority which is 1. Every router has all routers has a priority, and by default all router has a priority 1. So if all the router has a priority 1, then there is going to be a tie. So when there is a tie, then they are going to check the highest IP address. Okay, so tell me which router has the highest IP? 115. So then why 111 is configured as a DR? Because remember, the router you configure first, that become DR. Okay, first it check high priority. Okay, and the second thing, this thing is not in the books, that you will get to know when you do a lot of practicals. The router you configure first. The router you configure first will become DR. Okay, so when that priority got match here, तो हमारी priority set थी. We configured, we have same priority everywhere, priority 1. And the router you configure first is this router. And this is why this router become DR. But if you want to make this router 115 as a DR, you need to do DR BDR election again. And how you can do DR BDR election again? You have to give clear IP OSPF process command to reset the OSPF process again. तो ये कमांड आपको हर राउटर पे देनी है अगर आपको दोबारा से हाईएस्ट आईपी वाले को जिताना है. If you want to make the highest IP address as a winner, you need to give clear IP OSPF process everywhere. And there is a high chance it will give you correct detail, but till the time you do not get correct detail, you can keep doing that. But the best thing, guys, in real industry, it does not matter. Industry में matter नहीं करता कि कौन तुम्हारा DR है कौन BDR है. Okay, so in real world, it does not matter who is DR, BDR. So you do not have to worry that I want to make this router as a DR or BDR. Okay, because at the end of the day, this concept is created so that we will stop flooding. Right? So we clear, and now you can check show IP OSPF neighbor. In the neighbor, now you can see the 115 become DR, 1114 become BDR. So the highest IP became my DR. Backup DR is your 114 because after this IP is lower. So this is BDR. So these three router are going to be in which state? DR other. तो ये जो router होते हैं, these routers are going to be DR other. DR other, DR other, DR other. And do you know, DR other do not talk to each other. They do not share tables with each other also. Because all their information, they communicate with the DR only. So can you see, I am on router 2 and it is showing me 112 is a two-way state. 113 is also two-way state. So it means DR other, both all DR others, DR other, between DR other, you will always have two-way state. Remember this thing, guys. तो DR other और DR other के बीच में हमेशा two-way state होती है. What is two-way state? So two-way means that I am going to only send hello packet, that is called two-way. Okay. So what is two-way state, guys? So when we only send hello to each other, that is called two-way state. Okay. So it's written over here. Init means when you send one side hello, that is called init. And when you send both side hello, that is called two-way. So now tell me what they are doing. DR other, are they sending LSU to each other? क्या लग रहा है आपको DR other LSU भेज रहा है एक दूसरे को? Do you think they will send LSU, LSAC, LSR? No. They will never send any important message to each other. They will only send hello to each other. Then how they are going to share information with each other? How DR others will share routes with each other? I told you they have to inform to DR first and then DR will inform other routers. Okay? मतलब कोई भी बात करनी है पहले DR के पास जाना है तभी DR is like the monitor or the president of this network or like main member of the family, that anything you need to ask for the permission. Big boss, yeah. Okay. Okay, so now you got the DR BDR concept, right? So let me repeat again. तो DR BDR क्या होता है हिंदी में भी बोल देता हूँ. ओके तो DR BDR इसलिए होता है ताकि नेटवर्क के अंदर LSA फ्लडिंग ना हो. ओके तो जो भी हाईएस्ट आईपी एड्रेस वाला राउटर होगा वो DR बनेगा, उससे छोटे वाला आईपी BDR बनेगा. ओके द हाईएस्ट आईपी एड्रेस विल बिकम DR, द लोअर आईपी देन दैट विल बिकम BDR. And why we have DR BDR? So that we will reduce the LSA flooding. So the best part is that if any network goes down or anything happens, we will inform to DR first and then DR. So we inform DR BDR on 224.0.0.6 IP address, and then we are going to inform all other routers on 224.0.0.5. ठीक है? तो कोई भी करके देख लो, प्रैक्टिकली करके देखना, ट्राई टू डू दिस इन पैकेट ट्रेसर, you will definitely understand DR BDR properly. Okay, so now you understand DR BDR, but the problem, this DR BDR is in Ethernet technology. It means if you use two routers, if you configure these two routers, there is high chance, because this is giga Ethernet cable, and if you configure like any IP6111, and if you configure here also 6112, okay, so if I configure OSPF here on these two routers, so guys, do you think they will be having DR BDR election? Okay, क्या आपको लगता है यहां पर DR BDR होगा? Do you think there will be a DR BDR election? Okay, which technology Giga Ethernet is? This is also neighborship came up, right? And if you go and see the first router and see show IP OSPF neighbor, so can you see use other side is the router DR? दिख रहा है सामने वाला router क्या है? This highest IP, because this is 6111 and this is 6112. Okay, so this router 6112 is working like what? DR for me. Okay, and this router obviously is going to be BDR. Okay, one will become DR, one will become BDR. But if you have bigger network like this, the other routers are going to be DR others. Okay, so that is the concept. So in my lab, what I have shown you, this lab, okay, in this lab, so how many routers are there in area 0, 1, 2, 3, 4, and all are fast Ethernet? So tell me, how many chances, how many routers can become DR here? Remember, for every network, there will be a DR BDR. Okay, so it's very easy to check in the database table. Okay, you go to R1. Okay, and run this command here, show IP OSPF database. Okay, so can you see how many DR BDRs network LSA? This is network LSA is generated by DR routers. तो ये जो LSA होता है, network LSA is generated by DR routers. So how many routers are DR here? 1. Okay, 13.1 is DR for two networks, for 12 and 13, and 13.3 also DR. So there are around 3 DRs in my network. How I came to know? Because these two IPs are same. Can you see 13.1, 13.1? Ye same hai. So 27.2, 13.3. Okay, let me show you. 13.1 is DR for 13.1 is this router 1. Okay, and if I show you show IP OSPF neighbor, because in neighbor you cannot see your state. Neighbor में आपको अपना नहीं पता चल रहा. So you have to check show IP OSPF interface brief. Okay, so can you see my state here, guys? For my 13.1 network and 12.1 network, I am the DR. Because neighbor will show you neighbor state. Okay, so it means I am the DR for this network and this network, but other router, these two routers are BDR for these network. So this is why in the database table, you see these two IPs 2 times, that I am DR for 12.1 network. I am DR for 13 network also. Okay, the second DR is 27.2. 27.2 is this router 2. So router 2 is a DR for maybe this network. Let's check for which network is the DR. Okay, so show IP OSPF interface brief. Okay, so you guys can see I'm the DR. I'm the DR for 24.2, which is this side. Okay. And 27.2 के लिए भी मैं DR हूँ. Okay, so yeah, yes, we have 4 links, and in 4 links, like we have around 4 DRs, but for 2 links, 1 DR is like a DR for 2 networks. Clear, everyone? So router LSA will generated by all routers. मतलब कोई DR हो, BDR हो, even if it is ABR, ASBR, whatever, if that router is part of my area, I'm going to store all those routers in my area. Okay, let me show you how many routers do you see here. How many routers you see here, guys? Tell me. So in my database table, in the router LSA, how many LSA you will see? 5 or 4? How many LSA you see in the first section, guys? Please check. 5. But how many network LSA, how many DRs you see in this case? Only 1 DR. Because this is one network, remember? For every network, we will have DR, BDR election. So this 1111, all 5 routers are in my one network. This is why we have 1 DR here. But in this scenario, which I'm showing you here, so we have 4 routers, but they all are in 4 different networks. And this is why in 4 different networks, we will have 4 DRs. Okay, many students, they do mistake when we ask in interviews. Okay, tell me in one area how many DRs will be there. Area does not matter, guys. Area से नहीं पता चलता कि कितने DR BDR बनेंगे. Remember, area cannot tell us that how many DRs and BDRs we will have. We will only be able to see according to the links we have and how many networks, how many different networks we have. We have 1, 2, 3, 4. So now tell me R4, R5, R6 are in one network. So these 3 routers will be having 1 DR or like multiple DRs. ये 3 एक ही area में है. These 3 routers are connected with the switch and they all are in one network. So R4, R5, R6 will have 1 DR, correct? Okay. So let's configure R5, R6 also. I think we have given IP on R4. Okay, R5 and R6 पे भी कर लेते हैं. Okay, so this is R5. Enable config T, host name R5, interface F is 00, IP address 192.168.45.5. Right? IP OSPF 1 area 2. Okay, R5 is done. R6 is remaining. So R6 is also in area 2. Enable config T, hostname R6, interface F is 00, IP address 192.168.45.6. Area 2. ठीक है. So if you check the database of R6, what do you see? How many LSA we will see in the database table for area 2? Because this router participating only in area 2. So this is how many routers are in area 2? Tell me, guys. Kitne router in area 2 mein? How many routers we have in area 2? 3. So how many LSA you see in router area 2? 3. How many DRs are there in 3 routers? I think 45.4 we configured first, right? Yes. This is why the 45.4 become DR, and this is why in the network LSA you see 45.4. Clear? Okay, I'll discuss about summary LSA. Okay, so summary basically means that routes from different area. So tell me 12, 13, 24, 27, 34. They all are different area routes, right? For area 2. Because I'm checking in AR6. For R6, 12, 13, 24, 27, 34, they are from area 0 or maybe from different area. And who is sending all these details to me? 45.4, which is DR. ABR, sorry. R4 कौन है? ABR है. R4 is ABR. So I'm getting 12, 13, 24, 27, 34 from R4. So it is generated by R4. Summary LSA are different area routes which ABR will share. ABR will share these area 0 routes with area 2, right? So this is why R4 is going to generate summary LSA, and that summary LSA you see 12, 13, 24, 27, 34 is generated by R4, and this summary LSA will go from one area to another area. Okay, तो ये एक एरिया को क्रॉस करके दूसरे एरिया में जाते हैं. These LSA will go from one area to another area. Okay, but our router LSA and network LSA, they do not travel outside the area. Okay, राउटर LSA जो होते हैं और नेटवर्क LSA होते हैं अपने एरिया से बाहर नहीं जाते. राउटर एंड नेटवर्क LSA do not travel outside the area, but summary LSA will travel from one area to another area. Okay, so tell me which network is this 45.0. Okay, so this 45.0, if I check on R1 पे 45 कैसा दिखेगा? Summary दिखेगा. If I check on R1, 45.0 will be checked, will be in my database table as a summary route. Yes or no? If I go to R1, this is R1 now. So if I check database table, okay, in the summary, can you see 45.0? I'm getting 45.0 from router 4. So who is sending this area 2 network? This 45 is shared with R4 to R1. Right? So R4 is sending me 45.0. This is why you can see 45.0 I'm getting from 45.4 ABR. So this is ABR. But there is another network which is 27.0 here. So 27 is coming from R2 to R1. This is why it is showing you R2 IP address, which is 27.2. Because 27.2 and 45.4 both are ABR. तो जितने भी summary LSA आपको दिखेंगे, all summary LSA will be generated by ABR routers. All router LSA are generated by all routers. All network LSA generated by DR routers. Clear, everyone? I'm sure you never got to learn so much of OSPF. Yeah? No? Yes? नींद में तो नहीं हो? मैं देखने आया हूं तुम्हें. Okay, good. See, DR, BDR, if you do not understand very well today, okay, maybe I'll share one more video of DR, BDR. Try to watch that also. Okay, try to understand DR, BDR. Okay, and also in today's class, I just my objective of this class from you, that you need to understand DR, BDR, and you need to understand little bit of database, what I have explained today. I'm not asking you to learn sequence number, checksum values, all these things. Those things we'll discuss in advanced classes. But as of now, you need to just understand how we configure lab. Okay. How you configure multi-area lab. This is what I want all of you. So try to do the same lab. Okay. I configured area 0. I configured area 2. Now you need to configure this area 1 section also. Like I'll show you one router R7. Okay. But rest, the complete topology, area 1, area 0, area 2. Okay. You need to configure, and you have to ping from router 7 to router 4 to router, like all routers should ping each other. So this is last router for today. I'm configuring interface FA00, IP address 192.168.27.7. Remember the router name 7, then all subnets are 7. Router 8, then all subnets are 8. Like that. You guys configure. Okay, so this is area 1. This is area 1. And what will happen once you configure this, like very soon you will be having neighborship up, because R2 is already configured and you can see loading done, means neighborship is up. And now if you check your database, instantly you are going to get all the routes. And you can see I'm getting 12, 13, 24, 34, 45, all from router 2, because router 2 is responsible to share all the routes in this area 1. Okay. So how many routers are active here? I configured R7 and R2. This is why you see how many LSA? 2 LSA. So between R7 and R2, who is DR? Router 2 is DR. Okay. And all these routes are coming from area 0. And this is why you see summary LSA. Okay. But if you check here, are you getting the routing table routes in database? Yes. So whatever you see in the summary na, तो जो भी आपको summary में दिखता, all your summary routes, because they are different area routes. So in the routing table, they are visible as OIA, because OIA means OSPF, IA means inter area, means different area. Inter looks like, sounds like same area, but inter area is a different area in OSPF. ठीक है, तो ये आपको सारे रूट आ रहे हैं. Okay, so this is how, why we use routing, right? All the routes are coming from one network to another network. This is why we configured OSPF. Okay, so this is the lab. I don't know like why you do not have to configure this section. Ignore that. And do not also enable these routers. Just work on these routers and complete this lab. Okay, so
Hello.
yeah.
I have confusion. I already mentioned in the chat, and Chandan told that, right? So when we send hello packet, and then we will send DVD packet, right? So in that there will be summary, okay? So the other router can compare, and which this router don't have the IP, can compare, and we can accept those.
No, without IP, they will not compare. We need to have hello community. Hello will be shared when you have IP address and OSPF configured, right? Then only they will send hello to each other.
Yeah. But what I'm asking, so both will send hello, okay? And then one router will send DBD to other router, and this router will compare if I have those IPs or not, okay? So if this router don't have those IP, it will request, correct, to other router that I don't have.
Yeah, subnets basically you are asking. Subnets, not IP.
Yeah, the network ID it is, right?
Yeah.
So why again we need to send the network ID? Already in summary we are sending the network ID. No, this router can accept those if this There is no.
No. DBD is not just to accept all the data. DBD is to compare. See, the database table right now in my lab, it's not a very big lab, but still you can see this complete database table. Let me share my screen again. Okay, so you can see this is a complete database, right? So, so this is a normal configuration. Just imagine if you have 100 plus routers and the database size is very, very big. So instead of sending all the routes, the DBD packet is like a summary packet. Like suppose you read a chapter in book, right? So after completion of the chapter, there are some pointers like summary. Okay, that you studied all these things in this chapter. So it is not the complete information. It is just a bifurcation or it is just a summary of that particular data. तो वो summary क्या है, बहुत छोटी information है. It is not the complete table. Okay, it is not the complete database. The complete database, all information you send in the link state update, and inside a link state update you have all LSA. तो ये जितने हम LSA पढ़ रहे हैं ना, these LSAs are going inside link state update.
ठीक है.
Hello.
हाँ, समझ गया मैं. But अभी जो समरी है, वो समरी में सिर्फ आईडी रहती है, नेटवर्क आईडी रहती है, आप बोल रहे हैं ना?
Only summary.
Exactly, समरी में क्या रहता है उसमें मुझे?
So you guys just hold on. OSPF DBD. Okay, so if you open the DBD packet, okay, so normally it is just a block here and there is the sequence number. Okay, so you guys can see. So ये DBD packet का एक screenshot है. Okay, you guys can check in Wireshark also. Okay, so this is the init more master IMMS bit. This is what we will discuss this thing. But here, first of all, the MTU goes. Okay, because mostly the router accept that I am going to forward the data on a 1500 bytes MTU. The other side is also 1500. Normally, this is same. So you can see there is a sequence number. And can you see on the screenshot like you are sending multiple DB description, DB description, DB description? Can you see that?
Yes.
दिख रहे हैं आपको? So when you send DBD packet, you do not send just one packet, you send multiple DBD packets. Right? In all those DVDs, you will have those information, whatever you are sending, whatever prefixes you are sending. Okay? But you will not send the complete information. I hope you got the point. Right? You will not send the complete information. This is just that this is how many LSAs we have. I have like 4 router LSAs. I have 5 network LSAs. I have 5 summary LSAs. All right. Only I am just sharing the small information about the table. तो मैं पूरी information नहीं भेज रहा हूँ. मैं थोड़ी information भेज रहा हूँ. और वो सारी फिर हम ये देखो DBD इतने सारे गए हैं that I am sending a lot of DBD packets. And then we will compare and okay, this is how much we have, how much we do not have. All right. So this is what we have. Also, we'll discuss, like if you check here in any of the router, show IP OSPF database. So you can see there is a sequence number also, guys. Can you see that? Yeah. So this sequence number basically means that if you have any new update, agar is network par, if on this network, if there is new network update, maybe a slash value got changed, subnet mask got changed, this value become 8006. And when this router receives the 8006, the router is going to update 8006 because that is a new information. So where sequence numbers are used to check you are sending the new information or you are sending the old information. अगर आप update भेज रहे हो, if you are sending update with the same sequence number, the router is going to reject the packet because you already have 8005 sequence number information. So when you send 8006 information, then only the router is going to accept that information. So when you send DBD packets, okay, so you are sending DBD packets to each other. They are going to compare the sequence number. And if that is a new information, then it will ask for link state request, give the update, and create a database table.
Okay.
Okay. Yeah.
Understood.
Yeah.
And one more doubt I have.
Mhm.
When we like there is a DR BDR, right? So
Mhm.
when the network fails, it will tell to DR with the 224.0.0.6, correct?
Mhm. Mhm.
Instead of that, we can put the IP 224.0.0.5, and that time only we can send to all packet. No, that will not then continue. Flooding will not happen. No.
कहाँ पे कौन से केस में कह रहे हो?
मैं क्या बोल रहा हूँ अभी एक राउटर का नेटवर्क फेल हुआ है तो वो क्या करेगा कि डीआर को पहले बोलेगा कि हाँ ये मेरा नेटवर्क डाउन हुआ है करके फिर डीआर सबको डिस्ट्रीब्यूट करेगा बोलेगा कि हाँ ये नेटवर्क डाउन हुआ है करके अगर वही करने से हम डायरेक्टली ये आईपी डाल के सबको बोल सकता है ना वही राउटर जिसका फेल हुआ है
नहीं ऐसे नहीं होता ना. This is why the OSPF has concept. Okay, so try to understand when there is a network down, DR, any router will inform DR first because DR is a responsible guy. Okay, because if you do not have DR BDR elections, what will happen? You will send update, which will update to all routers, and these router will again send that update to all routers because all routers are neighbor of each other. So in OSPF, whenever you get any problem, you update neighbor and neighbor update their neighbor. So just imagine 5 routers are neighbor. If you get any problem, you update to 5 routers and those 5 routers update their 5 routers. Are you getting my point now?
Yeah, but this can be happen when DR send the packet no to all router.
हाँ.
मैं क्या बोल रहा हूँ कि जब डीआर इन्फॉर्म करता है सब नेटवर्क को कि ये नेटवर्क डाउन हुआ है तो वो भी फ्लड क्यों नहीं होता है वो मैं पूछ रहा हूँ
वो okay. So when you update the DR and when DR update other routers, why that is not flooded?
Yeah.
Because DR is having full neighborship with all the routers. पूरा database है ना, all routers have full database connectivity with the DR router.
Okay.
So obviously we need to have communication with the DR properly. We will share all information with the DR. I got your point. You are saying like when you get any problem, you inform DR. DR is updating all the routers. ना 5 सबको तो बता रहा है. DR is updating all the routers. But when that information is coming from DR, okay, remember the rule. Whenever you get any problem, you will update DR only. So when 2240, you get any 224005 update, okay, so these routers are just going to say, okay, thank you very much, because that information is sent by the boss DR. You will not forward that information further and further because directly DR is
why that router only, the faulty router only do the same thing? No, why this router is not doing that? The same thing means the router which having the issue, no, the network gone down. That router only can put the IP 224.0.0.0.5, no? So all router will understand, okay, so this network is down. And they will not.
So basically, either you do not understand properly or either you challenging OSPF technology.
No, I'm just trying to understand why.
Yeah. So first of all, it's very simple. Whenever a network down, you inform DR and BDR routers, right? And when DR, BDR, they update in the database and then they create another packet and create 22005 update. Okay. Try to check again, create a packet tracer lab similar like this. I will try to add one more video of DR, BDR. Try to understand the concept. Try to check in packet tracer what is going inside. Okay, what is happening. Then you will come to know exactly what I'm trying to say. Maybe you have not done any practical, or maybe you are thinking in mind, maybe that packet is not flowing what you are expecting. ठीक है, एक बार आप पैकेट्स को प्रॉपर चेक करो कि क्या हो रहा है. Then obviously everything has a logic here in OSPF. Like whenever any problem happens, you update DR, BDR, and then DR, BDRs are responsible to update other routers. Because if you do not have DR, BDRs, what will happen? Then you will have a LSA flooding issue in the network. DR, BDR is there to reduce LSA flooding. You cannot eliminate LSA flooding first of all. तो सभी लोग यह याद रखना कि LSA flooding खत्म नहीं होती है. Okay, LSA flooding, obviously, LSA flooding is a good thing also sometimes, because you need to inform other routers how you will update other routers. So up to some level, up to some extent, it is a good thing. But if it is creating a problem, if routers are getting high, CPU is getting high, memory is going high, then it is a problem. And this is why we have areas and DR, BDRs. Okay. Hello, hello.
Okay.
Yes, sir.
Okay. Okay, so this lab you guys have to complete, and tomorrow we'll see the next part. Yeah, so we'll see about type LSAs again, type 1, type 2, type 3 we discussed today. Okay, but we'll see other OSPF special areas also, which is called like stub areas. Okay, like why we have all these. Okay, so, yeah, tell me.
सर जो टोपोलॉजी है स्विच से बहुत सारे हमारे राउटर कनेक्टेड हैं, तो ये टोपोलॉजी सर मतलब प्रोडक्शन नेटवर्क में कहाँ पे यूज होती है सर अपने कंपनीज में?
सी प्रोडक्शन नेटवर्क में जैसे मैंने जो केस देखा था कि नॉर्मली जैसे हमारी 5-6 ब्रांचेस हैं, दिल्ली, मुंबई, चेन्नई, कोलकाता एंड ऑल. ठीक है. So suppose all those locations have a MPLS link, and those MPLS links or maybe those private links are terminating to one data center. So ये जो switch है ना, आप समझ लो ये एक switch है जो data center का switch है कोई. So all these links from different branches are connecting to this core switch. Okay. And this is where you will have this kind of design, where you are connecting all your, because आप सोचो ना दिल्ली, मुंबई, चेन्नई, like if you have 5 locations or 20 locations, do you think 20 locations will be connected together with each other with the 20 links? अगर आपकी 20 ब्रांच ऑफिस इंडिया में, तो आपको लगता है 20 ब्रांचेस 20 लोकेशंस के साथ 20 लिंकों से जुड़ी होंगी?
ओके, ठीक है,
समझ आ रहा है?
हाँ.
So if you have 20 locations, okay, if you want to connect your 20 locations, maybe you are connecting maybe just at one location, maybe one head office, maybe at one data center. Okay, so when you are connecting all those locations links to you, okay, maybe at that point of time you are using a switch like kind of a core switch. Okay. So I have seen this in Apple, where they have a lot of office in India, they have third party sites in India, okay, in different countries also, but all those locations, like in Mumbai and Chennai, they have data center. Okay. So all those locations, around 15-20 locations of Apple in India, those 15-20 locations are connecting in Mumbai and Chennai. In that case, like they are using and they are connecting all those locations with MPLS links, and those MPLS or private links are actually connecting multiple offices together, but all those offices links are terminating to a switch. That is like Cisco, I do remember a 6500 or some kind of switch.
Okay.
Amit will discuss about states tomorrow. Okay.
Okay.
Sir, hello.
Yes. Yes.
Sir, I
Hello.
have a question.
Yeah,
Sir,
Vaishnavi.
सर अब मल्टीपल एरिया जब कॉन्फ़िगर करते हैं तो सर सारे एरियाज मतलब डिफरेंट एरियाज में सब डीआर सबके अलग होंगे डीआर बीडीआर.
Yes, correct. Every network has a DR BDR. I told you area पे depend नहीं करता है. हर network, if you have 10 different networks, even you have 2 areas or 5 areas, that does not matter. If you have 10 different networks, then you will have 10 DRs. Okay. Every subnet will have a DR and BDR.
Okay.
Hello, sir. Hello, sir.
Yes.
Sir, if router R1 and R2 connected each other and they'll share a hello packets first. After next step, they'll share DBD, right? So in R1 and R2, among those two, which one will share DBD first?
So the router who becomes master, which with the highest router ID.
Okay, which means
Okay, so
DR.
there is a master and slave relation. Like this is 6112 is like master router now. Okay, so once we send hello, then they select a master slave something. So this router is like a highest IP. So this is master. So we will send DBD. This router is going to send DBD first, the DR.
Okay, can we say like DR will share DBD first?
Yeah, you can say that.
Okay, thank you, sir.
Okay, so I'm closing for the day, guys. Thank you very much.
Thank you,
Bye-bye.
sir.